Hello everyone. Today I'm here with you all with the topic surface area and volume for class 8th. In our previous classes we have learned how to find the area of the plane figures, that is your two-dimensional figures like your rectangle, square, triangle, all this we have learned. In this video we will be learning how to find the surface area, volume and capacity of three-dimensional figures, that is your solid figures like your cube, cuboid and cylinder. So first of all, what surface area is, what volume is, what capacity is, we'll be learning, and then we'll be learning how to find the surface area, volume and capacity of these three solids, that is your cube, cuboid and cylinder. So first of all, what surface area is? Like in the cases of your rectangle and in the case of your square, we were saying that the area of the square is side into side. Area of the rectangle is length into width. That means these plane figures were having only two dimensions, that is your length and width. But when we are talking about solid figures, they are having three dimensions. Instead of two dimensions, they are having three dimensions. Along with length and width, they are having height also. So example of cuboid, you can take it as your book is an example of your cuboid, your box is an example of a cuboid. All these are the examples of cuboid where all the faces are your rectangular in shape. But when we are taking an example of cube, then all its faces are your square. So what surface area is? Whenever we are adding areas of all the faces of a solid figure or the solid body, it is your surface area. For two-dimensional figures, we are using the term area, but for three-dimensional figures, we are using the term surface area. So whenever we are adding areas of all the faces of the solid figure, then we are getting the surface area. Now what volume is? Volume is the amount of space occupied by any of the solid body. Whatsoever the space is occupied by any of the solid body, that gives its volume. And capacity is the quantity that a container holds, or we can say internal volume of the container. If container is your empty, then whatsoever the space is there inside the container, whatsoever the quantity it can hold, that will give us the capacity or the internal volume. Now let's see, suppose I am taking an example of a cuboid. This is a cuboid whose all faces are your rectangular in shape. Suppose this is the length of the cuboid, this is the width of the cuboid, and this is the height of the cuboid, right? So if the sides of the cuboid is having unit of your centimeter, if side is your in centimeter, then its surface area will be having unit your square centimeter. The unit of the surface area will be your square centimeter, and the unit of the volume or your capacity will be your cubic centimeter. Similarly, if the unit of the sides will be your meter, then surface area will be in square meters and volume will be in cubic meters. This will be the units. If whatsoever the unit of the side is there, square of that unit will be the surface area, and the unit for your volume will be your cubic units. This is how we will be finding the units for surface areas and volumes. Generally, whenever we are finding the unit for your any of the liquid or any of the gas, we take it in liters. Generally, we say no that like 1 liter milk, 2 liters milk, 3 liters of oil. So whenever we are using for your liquids or the gases, we use the term liters. And what is the conversions of this liter? If we are taking 1 meter cube, in 1 meter cube there are 1000 of liter is there. In 1 meter cube there is 1000 liter, and when 1000 centimeter cube combined together, they form 1 liter. So this is how, if your volume is in meter cube, we can convert it into liter, or if it is in centimeter cube, then also we can convert it into liter. This is how we can convert the units. If the sides of the cuboid or cube is given in your centimeter, then the surface area will be in square centimeters and the volume will be in cubic centimeter. And if it is in meter, then surface area will be in square meters and volume will be in cubic meters. And we can convert cubic meters or the centimeter cubes in your liter also. Now coming back to your cuboid, let's see what will be the total surface area of a cuboid. Just now we said that cuboid is a box-like structure which is having all its faces as your rectangles. So this is a cuboidal shape. We can see over here it is a box and its shape is your cuboid. Over here we can see it is having your 6 faces, 1, 2, 3, 4, 5 and 6. It is having 6 faces and all these 6 faces are your rectangular in shape. We can see over here that the opposite faces are your identical even. This face is identical to this face. This face and the opposite face, which is your this face, is even identical. This face and opposite to this, which is your this face, it is even an identical face. So we can see over here in a cuboid there are 6 faces are there, 1, 2, 3, 4, 5 and 6. It is having 8 vertices, 1, 2, 3, 4 and 4 over here, 5, 6, 7, 8. So 8 vertices it is having and 12 edges it is having. So a cuboid is a shape, a solid which is having 6 faces, 8 vertices and your 12 edges it is having. We can see over here if this is the length of the cuboid and this is the width of the cuboid and this is the height of the cuboid. This is L, this is B and this is H. In that case, area of this face which is having its side as your length and your width B. So area of this will be L into B. We know area of the rectangle is L into B. So for this face it will be your L into B. Similarly, your this opposite face which is even identical to it, it will even having the area as your L into B only. So L into B for this face, L into B for this face. For these two faces, your area will be your 2 into L into B. Now, if we are going to consider this face, for this is your L and this is your H. So for this rectangular face, the area will be your L into H. Now we know that this face is even identical to it, opposite face. So for this face even your area will be your L into H only. So for this face and this face, these two faces, area will be your 2 into L into H. Now if we are going to consider this face is having your, this is B and this is your H. So area for this face will be your B into H. Similarly, opposite to this is the face which is even having area as your B into H. So area for these two faces will be your 2 times of B into H. Just now we said that the total surface area will be the sum of all the areas of all the faces of the solid figure. So this cuboid is having 6 faces and area of these 6 faces is your, for 2 faces it is 2 into L into B, for 2 faces it is 2 into L into H and for 2 faces it is 2 into B into H. So this is the area for the 6 faces. So total surface area, that is TSA, for the cuboid will be 2 into L into B plus 2 into L into H plus 2 into B into H. This will be the area of the 6 faces. Over here we can see that 2 could be taken common. So 2 we have taken common. Remaining will be your LB plus LH plus your BH. So this is the formula for finding total surface area of a cuboid, which is the area of the 6 faces. We have taken all the 6 faces into consideration. We have taken out the area of all the 6 faces and we have added it. So the total surface area for the cuboid is 2 into LB plus LH plus BH. This will be the formula for finding total surface area of the cuboid. Now, if we will be removing the topmost surface and the bottommost surface, if we are considering, suppose we are considering our room. This room is even cuboidal in shape. So if we will be removing the topmost surface, that is roof and the floor, then we will be having 4 walls only. So if we are considering only the 4 walls, then the area of these 4 walls is your lateral surface area. When we are removing the area of the top and the bottommost faces, then the area of 4 faces will be given by your lateral surface area. So which faces we are removing? We are removing this face and we are removing this face. Area for this face will be L into B. Similarly, it is the opposite face of it. So area of this will even be L into B. So we are removing this part. Now the area of the remaining 4 walls will be your 2 into L into H plus 2 into B into H. What we have done is we have ignored or we have removed this face and we have removed this face. We are only considering these 4 faces. Only these four faces we are considering. We are not considering this face and we are not considering this face. In that case, area of these four faces will be, area for this will be L into H. Area for this will be B into H. Again, opposite to this, it will be L into H, and opposite to this will be your B into H. So area of these four faces will be 2 times of L into H plus 2 times of B into H. This area is known as your lateral surface area. Over here we can see that 2 and H could be taken common and remaining will be your L plus B. So this is the formula for finding lateral surface area of a cuboid. So the total surface area, which includes all the 6 faces, will be your 2 into LB plus LH plus BH. And if we are removing your topmost and the bottommost faces, in that case it is your lateral surface area, which is given by 2 into H in the bracket L plus B. So as per the question, we will be deciding what formula we have to use. If we have to paint only the 4 walls, we need not to paint, we are not supposed to paint your flooring even and your topmost roof even. If these two faces we are not painting, in that case we will be considering these 4 walls only, and that will be taken from your lateral surface area. And we know that there are windows are even there, doors are even there on the 4 walls. So we will be removing the areas of the windows and areas of the doors also from this lateral surface area. If we have to do the flooring, in that case we will consider the area L into B, because this is the floor part, this and area of this face will be your L into B. So if flooring is to be done, we will be considering the area L into B. If we have to work on the roof, in that case also we will be considering the area your L into B. So whatsoever is to be done, if paint is to be done only on the 4 walls, then lateral surface area will be considered. If flooring is to be done, then we will be considering this area, that is L into B. So according to the question, we will be deciding that what area we have to consider. Now let's see how to find the surface area of a cube. Just now we have seen that cuboid is having 6 faces, 8 vertices and 12 edges. Similarly, cube is even having your 6 faces, 8 vertices and your 12 edges, and all its faces is your square in shape. Like if in the case of cuboid, the length, width and height we were taking, all the 3 dimensions were different, right? Now if all the 3 dimensions of a cuboid are equal, that means length is equivalent to width is equivalent to height, then we are getting the shape of a cube. So how cube looks like? It is having your 6 faces and all its faces are your square in shape, like this. Its length, suppose it is your A, so your width will even be your A and its height will even be your A. So all the 3 dimensions, that is your length, width and height, are equal in the case of your cube. Now just now we said that if we are going to add area of all the faces, we will be getting the surface area of the solid figure. Over here we can see that all the 6 faces are your square in shape. We know the area of the square is your side into side. So area of the topmost and the bottommost faces will be your A square plus A square, that is your 2 times of A square. Similarly, the areas of your this face and this face, opposite faces we are considering. So this face will even be your A into it, that is A square, and area of this face will even be your A square. So area of these 2 faces will be 2 times of A square. Similarly, this face, front face and the back face, area of these 2 faces will even be A square. So area of these 2 faces will be your 2 times of A square. So the total surface area, or we can say surface area of cube, will be given by 2 times of A square plus 2 times of A square plus 2 times of A square, that is 6 times of A square, where A is the side of the cube. All the 3 faces, all the 3 sides will be equal. Length will be equivalent to width, will be equivalent to height. So we have taken this side as your A. So total surface area of the cube will be 6 multiplied by your side square. This is the total surface area or the surface area of cube. Now again, if we are going to ignore, we are going to remove the topmost face and the bottommost face. Only we are considering all the 4 walls, only we are considering, then we will be getting your lateral surface area. That means we are considering the 4 faces only, and for every face area is your A square. So the area of the 4 faces will be your 4 multiplied by your A square. this will be the area of your lateral surface area when we are considering the four faces. Topmost and the bottommost faces we are not considering. Then we will be getting lateral surface area of the cube, and the formula for finding lateral surface area of the cube will be your 4 multiplied by your a square. Now, if we are going to consider the diagonal of a cube, so formula for finding diagonal of a cube is your root 3 times of your side. If we are going to multiply the side by root 3, we will be getting diagonal of a cube. Similarly, diagonal for cuboid, it is given by your root of L square plus B square plus H square. This is the formula for finding diagonal of a cuboid, and this is the formula root 3 into side is the formula for finding diagonal of a cube. So these are the formulas which we will be using for finding total surface area, lateral surface area, diagonal of a cube. Now coming to your cuboid. Cuboid already we have taken. Now we are considering your cylinder. Now we are coming to your cylinder. Like in the case of cuboid and cube, all the faces were your plane faces were there, flat faces were there. But in the case of your cylinder, we are having your curved face even, and we are having the plane face even. Your cylinder looks like this. Shape of the cylinder is like this. Pipe like structure is there, whose topmost and the bottommost faces are your circular, and this face is your curved face. So it is having two flat faces, that is your circular faces, and one is your curved face it is having. So if we will be adding area of all the three faces, we will be getting total surface area of the cylinder. Now how we can get it? Topmost face and the bottommost face, we know it is circular, and the area of the circle is your pi r square. So for this face it will be pi r square, for this face it will be pi r square. So for these two faces it will be pi r square plus pi r square, your 2 pi r square will be the area. Where we are considering that the radius of this circular path, this circular region is your r, and the area of this circular region is even your r. These two are identical circles and they are kept one over the other. They are just kept one over the other, and the center of this circle and the center of this circle, if they are going to join together, then they will be perpendicular to your base. Such type of cylinders are known as your right circular cylinder. When the circles, center of the circle of both the two, if we are going to join together, then if this line is perpendicular to the base, such type of cylinders are your right circular cylinder. There are other types of cylinder also, but here we will be learning about right circular cylinder only. Now how to find the area of this curved face? Topmost and the bottommost faces area will be your 2 pi r square, and height of this height, when we are going to join the center of these two circles, the distance between the center of these two circles will give us the height of the cylinder. So how the cylinder will look like? This is the circular face, this is even the circular face, this is the center of this base, this is the center of this base, and if we are going to join it together, then this gives us your height of the cylinder. This is the radius of the cylinder, this is radius for the circular part, this is circular region. So radius of these two circular region is small r, and this is the height of this cylinder. If this is the case, now how to find the curved surface area of this cylinder? So what we can do is, we can take a rectangle. This is a rectangle we can see over here. If this portion, this width of this rectangle is equivalent to height of your cylinder. This is the length of the rectangle, this is the width of the rectangle. If the width of the rectangle is equivalent to height of your cylinder, and length of this rectangle is equivalent to your circumference of the cylinder, if this is going to exactly overlap, then this is equivalent to your circumference of the circle. That means length of this rectangle is equivalent to circumference of the circle, whose radius is your r, and width of this rectangle is equivalent to your height of the cylinder. In that case, it is going to exactly cover your curved surface. It is going to exactly cover your curved surface. So the curved surface will be given by area of your rectangle, and area of rectangle is given by area of rectangle. We know it is your L into B, where this L is equivalent to circumference of the circle, that is your 2 pi r, and width is equivalent to height of the cylinder, that is your H. So area, that is your curved surface area of the cylinder, curved surface area of cylinder will be 2 pi RH, will be given by your 2 pi RH, because this is the area, area of the rectangle is equivalent to area of your curved surface area of the cylinder, because it is going to exactly overlap your curved surface of the cylinder. So curved surface area of the cylinder will be your 2 pi RH. Now if we are going to add the areas of this circle and this circle, it will give us the total surface area of the cylinder. So total surface area, that is TSA, of cylinder is given by your 2 pi RH plus 2 pi R square. For this circular region it is pi R square, for this circular region it is pi R square. So for both the circular regions it will be your 2 pi R square. So if we are going to see over here, 2 pi R is common, so it will be 2 pi R plus H. This is the formula for finding total surface area of the cylinder, and this is the formula for finding curved surface area of the cylinder. So whatsoever is given to you, accordingly we will be selecting that what area is required and what is the formula, and we will be solving it accordingly. Hope it is clear that what the total surface area of any of the solid is. If we are going to add areas of all the faces, we are going to get the total surface area of that particular solid figure. So total surface area of the cylinder is given by 2 pi R plus H. Whenever we are considering area, its units will always be your square units only. Now let's understand how to find the volume of these solid figures. Just now we said that volume is the space occupied by any of the solid figure. So first of all, coming to your cuboid. First of all, we are taking cuboid. See over here, cuboid is like this. All the faces are your rectangular in shape. This is the shape of a cuboid. So if we are going to consider the area of the base, if its length is your L, if its width is your B, and if its height is your H, then if we are going to multiply the area of the base, that is your whatsoever the face is there at the bottom, the area of this face will be your L into B, because for dimensions for this rectangular face will be your L and B. So this area of this face will be your L into B. If we are going to keep same type of rectangle, means identical rectangles one over the other up to your H height, we will be getting a cuboid. We have taken so many rectangular faces that are identical to each other. All the rectangles we have taken which are identical, whose length is your L and whose width is your B, and we have kept one over the other. Then the shape up to H height we have taken, so the shape we will be getting will be of your cuboid. So how we can get the area volume of a cuboid? If we will be multiplying the area of your bottommost face by its height, we will be getting its volume. So volume for cuboid will be volume of cuboid is base area multiplied by your height. Base area is your L into B and height is your H. So volume of the cuboid is given by L into B into H. And if your sides are in centimeter, then the unit for your volume of the cuboid will be is cubic centimeter will be the unit. So whenever we are multiplying the base area by its height, for the case of cuboid I am talking about, then we are getting the volume of the cuboid, that is your L into B into H. Similarly, if we are going to consider your cube, so cube, for cube all the faces are your square. Just now we have seen that all its faces are your square, whose sides are your A. Length is also A, width is also A, and height is also A. So for this case, area of the base, area of this face will be your A into A, because all its faces are A only. All its sides are your A basically. Length is A, width is A, and height is even A. So area of all the faces will be your A into A, that is your A square. So for the bottommost face or the base area will be your A into A, that is A square, and height is your A. That means if we are going to take squares whose sides is your A, and we are going to keep one over the other up to A height, then we will be getting the shape of a cube. So volume of the cube will be volume of cube is given by base area multiplied by its height. Now all the sides are your A. So base area will be A into A, that is A square, and height is also A. So A cube, that means your cube of the side will be the volume of the cube. Volume of the cube is given by your side cube. If we are going to multiply side 3 times, side into side into side, we will be getting volume of the cube. Now coming to your cylinder. Just now we said the cylinder is having your two circular faces and one your curved face. So if we are going to keep the circles of the same radius, we have taken circles with the radius r. This is the circle and this is the height of the cylinder and the radius of the circle is your r. If we will be taking circles of r radius and we are keeping one over the other, same circles we have taken, and up to h height if we will be keeping it one over the other, then we will be getting the shape of a cylinder. So again the volume of the cylinder will be given by volume of cylinder is again your base area multiplied by its height. Now base is your circular and area of the circle is given by your pi r square. Height is your h. So volume of the cylinder is given by pi r square h will be the formula for finding volume of the cylinder. So this is how we can find the volume of the cuboid, volume of the cube, volume of the cylinder by multiplying the base area by its height. So volume of the cuboid will be L into B into H. Volume of the cube will be side cube and the volume of the cylinder will be your pi r square h. All these are the volume which shows the space occupied by these solid figures in the space. How much space they are occupying, this is shown by the volume. And if we are talking about the capacity, then we will be talking about your internal volume. In the case of your capacity, we are talking about the internal volume of the particular solid. Now let's see the application of the surface area and volume of the given figures, where we can apply it, how we can solve the questions based on these type of concepts. Now see, if there is a box is given to us and we have to find the space occupied by the given box, then the space occupied by the given box will be given by your volume, external volume. External volume of the given solid will give us the space occupied by it. If we have to find the capacity of the box, in that case what required is your internal volume is required to us. What gives us your capacity? Capacity is given by your internal volume of the box, gives us the capacity. Now what the volume of the material will be? That means if from the external volume we will be subtracting your internal volume or the capacity of the box, then we will be getting volume of the material. Suppose I am saying that the radius of your circular, if I am talking about a cylinder, and cylinder is having inner radius as your 5 centimeter and the outer radius is your 6 centimeter. That means the thickness of the material whichsoever we have used for constructing, for making your cylindrical box is your 1 centimeter, because inner radius is 5 and the outer radius is your 6. That means thickness of the material is your 1 centimeter. So how we can get the volume of the material? If from the external volume we will be subtracting your internal volume, we will be getting volume of the material whichsoever is used for making the either your box or whatsoever the solid we are talking about. So volume of the material, if we have to find, what we will be doing is from the external volume we will be subtracting your internal volume. If we will be subtracting these two, we will be getting volume of the material. Now suppose if there any of the room is given to us and we have to paint, not on the top even, on the floor even we won't be painting, and at the top even or the roof even we need not to paint. In that case what we need to consider is your lateral surface area we will be considering, because on the 4 walls only we will be painting. So that's the reason the lateral surface area will be considered. Now if any of the wall in the wall, if some window is there or the door is there, we will be subtracting the areas of the windows and the doors from these lateral surface area. So whatsoever is given to you in the question, accordingly you will decide that what is to be done. If flooring we have to do, then we will be considering the area of the floor only, that will be your L into B. And if we have to consider the roof, area of the roof, then again it will be your L into B. So whatsoever is required, accordingly we will decide what is to be considered. So if space occupied by any of the solid figure we have to consider, then we will be taking external volume. If its capacity is asked, then we will be taking the internal volume. And if its volume of the material is asked, then we will be subtracting the external volume and your internal volume. Now suppose there is a closed box is there. Then in this closed box, if the external length of the box, suppose we are taking it as it to be your say cuboidal box is there, and the external length, external width and external height are your L, B and H respectively. That means external length is given by your L, external width is given by B and external height is given by your H. In that case, and the volume of the wall thickness is your X units. Thickness of the wall is your X units. Then what will be the internal length, internal width and internal height? Suppose what is given to us is your that the external length, width and height of the cuboidal box is your L, B and H respectively. And the thickness of the wall is your X units. So thickness of the wall will be in the right hand side even and in the left hand side even. Both the sides we will be having the wall. Thickness of the wall will be considered both the sides. So your internal length will be your L minus 2 times of X. See, if this is the box we are talking about and we are saying that this is the external length from here to here. This is your external length and thickness of this wall is your X. And this is even X, so this X will be subtracted and this X will even be subtracted to get the internal length of this box. So the internal length of the box will be your, from the external length we will be subtracting the wall thickness of the wall 2 times. That will give us the internal length. Similarly, internal width will be given by your B minus 2 times of X. Thickness will be removed 2 times because both the sides we are having the walls of the box. So B minus 2x will be doing for getting the internal width. And the internal height will be given by H minus 2x will give us the internal height of the box. If your closed box is there whose length, width and height, external length, width and height is your LBH and the thickness of the wall is your X, then internal length will be L minus 2x. B minus 2x and H minus 2x will be the internal height, internal width and internal length. Now suppose instead of external dimensions, internal dimensions are given to us. That means internal length, internal width and internal height of the box is given to you as L, B and H respectively. And the thickness of the wall is your X units. Now in the internal length, if we will be adding the thickness of the wall here also and thickness of the wall here also, we will be getting the external length. So external length will be internal length plus 2 times your thickness of the wall. That will give you your external length. External width will be your B plus 2 times of X will give us your external width. And external height will be your H plus 2x will be the external height. So if we have to find what is the volume of the material, what we will be doing is from the external volume we will be subtracting your internal volume. That means if I am considering this as the case. So in this case external volume will be, volume is given by your L into B into H. This is the volume of your cuboid. So the external volume will be external volume minus internal volume will give you volume of the material. So external volume will be, external dimensions are here, it will be your L plus 2x multiplied by B plus 2x multiplied by H plus 2x, because L into B into H is your volume. So external volume will be, we have taken external dimensions minus internal volume. So we will be considering your internal dimensions, that is your L into B into H. So we will be subtracting these two, we will be getting the volume of the material used. So this is how we can apply the concept whatsoever we have studied in solving the question. Now let's see how to solve the questions. Now let's understand how to convert the units. We know that 1 centimeter is equivalent to your 10 millimeter. When we combine 10 millimeter together, we are getting your 1 centimeter. But if we have to convert it into centimeter square and millimeter square, so it will be 1 centimeter square will be 10 multiplied by 10 millimeter square, or we can say it will be your 100 millimeter square. Similarly, if we have to convert it into cubic units, then 1 centimeter cube will be 10 multiplied by 10 multiplied by 10, that is your 1000 millimeter cube. Similarly, if we have to convert millimeter or your centimeter and meter units, so we know that 1 meter is equivalent to your 100 centimeter. So if we have to convert it into meter square and centimeter square, so 1 meter square will be 100 multiplied by 100 centimeter square, or we can say it will be your 10,000 centimeter square. Similarly, if we have to convert it into meter cube and centimeter cube, so 1 meter cube will be 100 multiplied by 100 multiplied by 100 your centimeter cube. So this is how from the single units we can convert into square units and the cubic units. Now let's understand some of the questions. A cuboid of dimension 60 centimeter, 54 centimeter multiplied by 30 centimeter. That means length is your 60 centimeter, width is 54 centimeter and height is your 30 centimeter. How many small cubes with side 6 centimeter can be placed in the given cuboid? So when we have to replace or we have to place your cubes in your cuboid, that means volume of the cuboid should be equivalent to your volume of the cube. And in that case, how many cubes will be there? If there are n cubes of this dimension, then volume of these n cubes will be equivalent to the volume of the cuboid. So how we will be doing it? First of all, we will be finding the volume of the cuboid. Volume of cuboid is given by your L into B into H. Over here, L is your 60 multiplied by 54 multiplied by 30. This much of centimeter cube is the volume of the cuboid. Now, what the volume of the cube will be? Volume of cube. Side is your 6 centimeter. We know that the cube of the side will give us volume of the cube. That means 6 multiplied by 6 multiplied by 6 will be a volume of the cube. Now, this is the volume of one cube. Now, if we are going to say that there are n such cubes, then volume of n such cubes will be equivalent to volume of the cuboid. Now, we are assuming your number of cubes is your n. So, volume of n cubes will be n multiplied by your 6 into 6 into 6 centimeter cube. And in this case, volume of cuboid will be equivalent to volume of cuboid will be equivalent to volume of n cubes. We will equate it. Volume of the cuboid is your 60 multiplied by 54 multiplied by 30, and it is equivalent to volume of n cubes will be n multiplied by 6 multiplied by 6 multiplied by 6. So what the value of n will be? That means how many such cubes will be there which is going to be placed in the given cuboid. So what the value of n will be? N will be 60 multiplied by 54 multiplied by 30 divided by 6 into 6 into 6. Over here we can see 6 10 is 60, 6 these are for 6 9 is 54, and over here 6 5 is 30. So it will be 5 into 10 50, 5 9 is 45, 450 cubes are going to be placed in the given cuboid. So this is how we can equate the volumes and we can get the number of cubes which are going to be placed in the given cuboid. Now let's see another question. The length, width and height of a cuboid are in the ratio of 5:3:2. So first of all, we are assuming that the length of the cuboid be it is equivalent to, suppose, your 5x. So width will be 3x and height will be your 2x, because ratio between the length, width and height is given to us as 5:3:2. That means if length is your 5x, width will be 3x and height will be your 2x. If its volume is 240 centimeter cube, find its dimension. We know the volume of the cuboid is volume of cuboid is given by your L into B into H, and volume over here is given to us as 240. So 240, it is equivalent to 5x multiplied by 3x multiplied by your 2x. So if we are going to solve it further, it will be 240 is equivalent to 5 2s are 10 and 10 into 3 is 30. 30 x multiplied by x will be your x cube. So what the value of x cube will be? 240 divided by 30. 3 8 is 24. So value of x cube is 8. So value of x will be cubic root of 8, that is your 2. Value of x is your 2. And if value of x is 2, what the length will be? Length of the cuboid will be 5 into x, that is 5 into 2, 10 centimeter. Width will be 3x, means 3 multiplied by 2 because value of x is 2. So it is your 6 centimeter. And height will be 2x, that is 2 multiplied by 2, that is your 4 centimeter. So these will be the dimensions of the cuboid. Now also find the total surface area. Total surface area of cuboid, it is given by 2 into LB plus BH plus LH. This is the total surface area of cuboid. So it will be 2 multiplied by L into B, 10 into 6 plus B into H, that is 6 into 4 plus L into H, that is 10 into 4. So if we will solve it further, 10 6 is 60 plus 6 4 is 24, 10 4 is 40. So it will be 2 multiplied by, it is your 124. That will be 4 2s are 8, 2 2 is 4, 248 unit was centimeter, so it will be square centimeter. So this will be the total surface area of the cuboid. So this is how whatsoever is given to us, accordingly we will be solving the questions. Now let's understand some more questions related to it. The total surface area of a cube is 216 centimeter square. Find its volume. So total surface area is given to us, and we know that the total surface area of a cube, total surface area of cube is given by 6 multiplied by side square. This is the formula for finding total surface area of cube, and it is given to us as 216. That means 6 multiplied by side square, it is equivalent to 216. So what the value of side square will be? Side square will be 216 divided by your 6. So 6 3s are 18, 6 6 is 36. So square of side is your 36. So what the side will be? Side will be given by square root of 36. That means your 6 centimeter will be the side of the cube. Now we have to find its volume, and we know that the volume of cube is given by, volume of cube is your side cube. So it will be, side is your 6 centimeter. So it will be 6 multiplied by 6 multiplied by 6. That will be your 216 centimeter cube will be the side of the, volume of the cube. This is how we can get it. Now let's see the another question. Find the volume of a wood required to make a closed box of external dimensions 80 centimeter, 75 centimeter and 60 centimeter. The thickness of the walls of the box being 2 centimeter throughout. The thickness of the box is your 2 centimeter throughout. It is external length. External length is your 80 centimeter. External width is your 75 centimeter and external height is your 60 centimeter. It is given to us. And thickness of the wall, thickness of wall is your 2 centimeter. So just now we have read, if external dimensions are given to us and thickness of the wall is even given to us, then internal length will be external length minus 2 times of the thickness of the wall. That means 2 multiplied by 2, that is 4. That means 76 centimeter will be the internal length. Internal width will be 75 minus 4, that is 71 centimeter. And internal height will be, external height was 60. From 60 we will be subtracting 2 times of the thickness of the wall minus of 4, that will be 56 centimeter. Now for finding the volume of your wood required, what we will be doing is, from the external volume we will be subtracting your internal volume. So volume of the cuboid is L into B into H. So it will be 80 multiplied by 75 multiplied by 60, because external volume is given by L into B into H. So it will be 0, 0 here, 6 5s are 30, carry over 3, 6 7s are 42, 45 into 8, it is 0, it is 36. So this much of centimeter cube will be the external volume. Now what the internal volume will be? Internal volume will be internal length multiplied by internal width multiplied by internal height. That will be 76 multiplied by 71 multiplied by 56. And multiplication of all these three is your 302176. This will be the internal volume in centimeter cube. So what the volume of your wood will be? Volume of wood is external volume minus internal volume. It is equivalent to, we will keep the values over here. Now subtract it. 10 minus 6, it is 4. 9 minus 7, it is 2. Then again 9 minus 1, it is 8. Again 9 minus 2, it is 7. So it will be 35. So it is 5. This much of centimeter cube. 57,824 centimeter cube will be the volume of the wood. This is how we can get it. Now let's see the last question. Find the height of the cylinder whose radius is 7 centimeter. Radius is given to us as 7 centimeter. And total surface area. Total surface area is given to us as 1100 centimeter square. We have to find the height. We know that the height, total surface area of cylinder is given by 2 pi r plus h. This is the formula for finding total surface area of the cylinder, where pi is a constant whose value is your 22 by 7. So just keep the values. Total surface area is given to us as 1100. It is equivalent to 2 multiplied by 22 by 7 multiplied by value of r is your 7. In the bracket r, that is your 7 plus h. These 7 are going to cancel. 2 multiplied by 22. This will go over here in division. This is the value of your 7 plus h. So 11 2s are 22. 11 1 250 times 2 25 times. So 25 is equivalent to 7 plus r, and the value of h will be 25 minus 7. That will be what the value of h will be. From 15, if we'll be subtracting your 7, it will be 8, and it is 18. 18 unit is your centimeter. So height of the cylinder will be your 18 centimeter. So this is how, using the formula, we can solve the question. Hope it is clear to you. This is all from this chapter. Soon we'll be coming with the more chapters of class 8 maths curriculum. If you are having any doubt related to any of the question, you can comment me. I'll try to respond as early as possible. Thank you.